Good morning, fellow members. I'm going to explain you about the target mission in compiler design. Um, okay. First of all, what is mean by target mission? You have to know about the target mission for good code generation. Familiarity with the target mission and instruction set is important. Consider our target mission is a byte addressable machine with 4 bytes to a word, and there are n general purpose registers named as R0, R1, R2, or N. The next one is the target program code. The backend code generated of a compiler may generate different forms of code depending on the requirements. That may be absolute mission code, executable, and assembly language, bytecode from the interpreters. And the target mission opcodes is an example of move, add, and sub is the one of the basic sets of the target missions. And there is one of the main thing is we have to see this is an addressing modes of the target mission. First of all, you see that absolute is form of m and the address m added cost 1, which means the m have an cost of 1, and the register means the register R0 is an empty. The register is the one of the address. Okay, it does not can have the cost. And the indexed indirect register, indirect index, and literal. Index means C means constants. Constants C plus constant R. Constant R means it is an address of R. So it will combined with the number. So that will be the cost of 1. And the indirect resistance means it have the only the address. Constant address. So that consists of the added cost will be 0. And indirect indexed star C of R, which means constant that will be combined of indexed plus indirect registers. So that you have the 1. 1 plus 0 means 1. Okay. Then literal processor of 0 which have not anything else. And then we are going to see that one of the thinkers it consists of move R0 R1, which means the value will be stored in R1. We know already. Why the cost will be 1? We have to see that move consists of 1, because we see that in that m consists of 1. So it will be 1 here, and that we have to store a move R0 comma m. Now the value will be stored in m. Now we have to see that R0 will be have not a value. So move and m have an 1 and 1. So the total cost will be 2. And another one also that will be contained repeatedly. Move have 1, m have 1, so R0 will be 0. So the total cost will be 2. And then here we have to concentrate the thing. We have to see that 4 of R0, which means it consists of constants of R0. So it now the R0 have the value of 1, move have 1, and m have 1. The total cost will be 3. And also the same thing happened in this next step also. And now we have to concentrate this sign, the as of 1. So it will be the 1 and move have a 1. Now we have to add these two things. It will be stored in the R0. So we have to do. In the next step, add have 1, 4 of R0 have 1, star 12 of R1 have 1. So the total cost will be 3. As per the examples, the cost will be shown. And the instruction selection, addressing modes. Suppose we translate A colon B plus C. We have to see that move B, the R0 will be have the value of B, and now add of R0 plus C means B plus C is the main thing that will be happen in that place. Then the two value will be stored in A, which is R0 is the A. Assuming that we have to A. This is the one of the thing that happened. Instruction selection, which is one of the best thing we have to know that about the target mission is happening here. Instruction selection is important to obtain efficient code. Now you have to see x colon to y plus is equal to y plus z. Okay. Now you have to assume that the value of y is moved to R0, and the R0 have the value of y. Now add z plus R0 means the value will be added and stored in R0 because R0 is the end of the session. Okay. Now the R0 value will be stored moved to x. This will be happen. Now you have to come here, a colon is equal to a plus b. Now the same thing repeated. The a value of a will be stored in R0, and the value will be here is not value, x is equal to y plus z, there is no value, but here a plus 1 is a value, so processor will be stored in the same or not. Move or not comma a. Now you have to assume that cost. Now the R0 have no value, but m have a value, a have a value. Now the cost is 2. The next one, processor 1 have a value, R0 not have a value, add have a value. So the total cost 4. Now a have a value, move have a value. So the total cost will be 6. This will be happen here, and here better we have to see that add as 1 comma a. The all have a one value of 1. Each have a value of 1. So the cost will be 3. Here INCA. The two things having the value. So the cost will be 2. Thank you.